Hi guys, this is our second lecture for the chapter 1 real numbers of class 9, and today we will learn how to represent irrational numbers on a number line. Okay, so let's start it. Okay. Exercise 1.2, question number 1 is state whether the following statements are true or false. Justify your answer. First part is every irrational number is a real number. You know that real number is the biggest set of numbers in which all the set of numbers comes like natural numbers, integers, whole numbers, rational numbers and irrational numbers. So the question is every irrational number is a real number. So all the irrational numbers also come under the set of real numbers. So our answer is yes. Second, every point on the number line is of the form root m where m is a natural number. Answer for this is false because m is a natural number, and if I substitute n natural number values, so I'll get values as root 1, root 2, root 3, root 4, then the negative, it won't cover the negative numbers. So our answer is no. Third part, every real number is an irrational number. Its answer is also false because real number is the biggest set of numbers and irrational numbers come under it. All the real numbers are not irrational. We can take example 1 by 2. 1 by 2 is real but it's not irrational. Question number 2. Are the square root of all positive integers irrational? So what are they asking? Are the square root of all positive integers? If I take all positive integers and I'll do their square root like root 1, root 2, root 3, root 4, root 5. So for all, if I keep taking this, so they are asking is the root for square root of all positive integers is irrational. Here answer is false because if I take root 4 is what it is 2 and it is not irrational. Okay. If not, give an example of the square root of a number that is a rational number. So this is my example. Root 4 is not irrational because its answer is 2. Okay. Next, question number 3 is show how root 5 can be expressed on a number line. Now we need to learn how can we express irrational numbers on number line. First of all, I'll explain you the representation of root 2, root 3 and root 5 on number line because these three are very important representation. I'll explain it to you on the board. Then after that, with the help of compass, I'll explain it to you on the notebook. So firstly, just learn the steps. Okay. So firstly, we'll take representation of root 2 on number line. Okay, so what are the steps for this? The step is I'll take a number line, I'll take this point as 0, this will be my 1, this will be 2, this will be 3, and this is actually, when we will plot it on a notebook, this is actually my actual distance which we'll take with the help of compass. This is 1 centimeter. These are all gaps of 1 centimeter. Okay. Then if I want to represent root 2 on a number line or root 3 on a number line or root 5 on a number line, for this we'll take the help of Pythagoras Theorem. And what is the Pythagoras Theorem? It is hypotenuse square is equal to base square plus perpendicular square. In this actually what I want, we know that in right angle triangle, this is my base, this is perpendicular and this is hypotenuse. And the number that I want to represent on number line root 2, this number I want it as my hypotenuse. I want my hypotenuse as root 2. So this side, if I do, take square root, then hypotenuse will be equal to root of b square plus p square. And this hypotenuse value, what I want it as root 2. So now we need to think that what value of b and p I will consider so that my hypotenuse value will come root 2. So those numbers we need to think. So what comes in my mind, if I take value of b as 1 and value of p as 1, just check it. If I take it as 1, it's square plus 1 square. 1 square is what? It's 1 plus 1. It is what? It's root 2. So what I got, if I have taken the value of b as 1 centimeter, value of perpendicular as 1 centimeter, then I got my hypotenuse as root 2. So for plotting root 2 on a number line, we'll take the help of Pythagoras Theorem. So for this, I have taken my base as 1 centimeter. Base is what? It's 1 centimeter. Perpendicular is what? It's 1 centimeter. Then the hypotenuse that we will get will be root 2. Okay. So I have plotted a number line, and on this I have taken the actual distance with the help of scale. I need to take base as 1 centimeter. So we'll consider this as this 1 centimeter is my base, and I'll give it name O, and to this I'll give name as A. Now on A, with the help of protractor, with the help of compass, we'll make a 90-degree angle here. Like this, I'll make a 90-degree angle here. Okay. After making the 90-degree angle, I need to take the perpendicular. What perpendicular? I need 1 centimeter. So I'll open my compass 1 centimeter. I'll draw an arc here like this. This will be 1 centimeter gap. And this will be what? This is my base 1 centimeter. This is what? This is my perpendicular, which is 1 centimeter. And give it name B. Now if I join O with B, O with B, this is what? This is our hypotenuse, which will be root 2. This is what? Base is 1, perpendicular is 1, then hypotenuse that you will get, it will be root 2 centimeter. But our question is representation of root 2 on a number line. We got this distance as root 2, but this distance is actually not on number line. It's somewhere here. I want this distance on the number line. So what we will do, we'll put our compass here, we'll put our pencil here, and we'll draw an arc on number line like this. Extend your compass like this, and somewhere like this here, you will get your arc here, and this point C is what? C is what? This is your root 2. Okay, so this is what representation of root 2 on number line. Got it? Okay. Next is, if I want representation of root 5, representation of root 5 on number line. So for representation of root 5 on number line, again we need to take the help of Pythagoras Theorem, that is hypotenuse square is equal to base square plus perpendicular square. Now what I want my hypotenuse as root 5. So accordingly I need to choose B and P. Hypotenuse is what? It's root of b square plus p square. Now we need to think about the numbers, like what values I'll take for b and p, so that here after solving I'll get the number as 5. So what comes in my mind, if I'll take value of b as 2 and p as 1, or I can take base as 1 and perpendicular as 2. Just check it. It is what? I am taking base as 2 and I am taking perpendicular as 1. So what I am getting? I am getting 4 plus 1, which is root 5. So what I got hypotenuse as root 5. But when I got hypotenuse root 5, for that I need base as 2 centimeter and I need perpendicular as 1 centimeter. So we'll start the procedure again. We'll take a number line. On this number line, with the help of scale, we'll point 0, 1, 2, 3, 4, 5 and so on to. And after this, what I need to take? I need to take base as 2 centimeter. So consider 2 centimeter, this much distance, give it name O, give it name A. This is your base, which is 2 centimeter. Then on A, with the help of compass, we'll make a 90-degree angle like this. And we need to take perpendicular, which is 1 centimeter. So I'll cut an arc of 1 centimeter like this. This is what 1 centimeter distance, and I will give it name B. Now I have taken base as 2 centimeter, perpendicular as 1 centimeter. Now if I join the hypotenuse will be what? It will be root 5. But we don't want to take hypotenuse on here on the perpendicular. I want this root 5 distance on the number line. So I put my compass here, I'll put my pencil here, and I will draw an arc like this. This will be the arc. And give it point C, and its name is what? Its name is a C, which is root 5 centimeter. So this is what, how can we represent root 2 on number line, how can we represent root 5 on number line. Now next what we need to do, we need to do representation of, for this you will also you can write the steps of constructions, and steps of construction, it's not difficult, whatever you are doing you can just keep writing in the same way. Like first of all we'll say for root 2, if I want to write the steps, we'll write, draw a number line, then on that number line take distance OA as 1 centimeter. The second step, on A, draw a 90-degree angle and cut 1 centimeter arc and give it point B. Then join distance OB, this is what? This is root 2. Then keep next point, keep the compass on O and pencil on B, draw an arc on number line, which will give you point C, and point C is what? Root 2. So the way you are doing the steps, the same way you need to write those steps, okay? So next is we need to do representation of root 3 on number line. We need to do representation of root 3 on number line. Again, we use Pythagoras Theorem, which is hypotenuse square is equal to base square plus perpendicular square. Now what I want my hypotenuse now? I want hypotenuse as root 3. So for that we need to consider our base and perpendicular. So hypotenuse is what? It's root of b square plus p square. So just start thinking about, to get here number 3. How should I choose my base or my perpendicular? So for that I am taking base as root 2, and I am taking my perpendicular as 1. Just check. What is root 2 square? Root 2 square is 2 plus 1. So I got root 3. This one representation of root 3 is slightly difficult, because for the representation of root 3, I need my base as root 2 and perpendicular as 1. So root 2 base I need. So first of all, for representation of root 3, we need to firstly do the representation of root 2. After that we can do the representation of root 3. So it is actually two-step process. So firstly, again I'll take my number line. On this I'll take point 0, 1, 2, 3, 4 and so on up to. Then after that, first of all we'll make our base root 2. So how to make base root 2? We'll take this point as O, this point as A. On A I'll make a 90-degree angle like this way, and I cut an arc of 1 centimeter. This is 1 centimeter, this is 1 centimeter. Then the hypotenuse that I will get now is root 2. I told you for representation of root 3, firstly we need to plot root 2. So give it point B. Now put your compass on O, pencil on B, and draw an arc on the number line, and this point that you will get is point C, which is what? Which is root 2. This point I got root 2. So now I got my first step, which is representation of root 2. Now this root 2 distance, this distance I will take as my base. Now this O to C distance is what? Root 2, and this is my base. Then on C we will make a 90-degree angle. Okay, I'll make a 90-degree angle here on C, and we'll cut an arc of 1 centimeter. We'll give it name D. Now when you will join O with D, the distance that you will get, it will be root 3. Again, we don't want root 3 here, we want root 3 on the number line. So we'll put our compass here, pencil here, and we'll draw an arc on number line like this. Now this distance what I got is what? It is root 3 distance. Okay. So for representation of root 3 on number line, firstly I want representation of root 2 on number line. So now after this I'll just explain it to you on a notebook with the help of compass, scale and pencil. Now we will do representation of root 2 on number line. For this, firstly I will draw a number line with the help of scale, and on this number line I'll take the point 0, 1, 2, 3, 4 and some more points. Okay, this is what this point is 0, this point is 1, this point is 2, this is 4, this is 4, that's it. Give the point O name as 0 as O and 1 as A, because when I am doing root 2 representation I need to take base as 1 centimeter and I need to take perpendicular as 1 centimeter. After that on A make a 90-degree angle. Now we need to cut 1 centimeter perpendicular. So we'll open the compass for 1 centimeter like this and we'll cut an arc like this. This is what? This is point B, which is at 1 centimeter distance. Now join O with B. That's it. Now the hypotenuse that we got here, it's what? It's distance root 2. But we don't want this root 2 here on AB line, we want it on number line. So we'll put the compass on O and pencil on point B and we'll just draw an arc on the number line like this. Put the compass on O, pencil on B and draw this arc on number line. So the point that we got here is point C, which is root 2. This is what? This is representation of root 2 in the same manner. This is what? This is representation of root 2. In the same manner, we can draw root 3, root 5. Okay. Now, what we learned today, how to represent root 2, root 3, root 5 on number line. In the same manner, we can plot so many irrational numbers on number line. So do practice for more numbers, and that's the end of our lecture 2. And please keep liking my videos. Give in comment box, please write you want my next video on which topic and subscribe to my channel. Thank you and have a nice day.